Hey, good evening, everybody. I'm truly sorry for the late video, but let's get into it. So, now, all right, let's talk about inequalities. Yeah, what is an inequality? So, let's see. This is a mathematical statement, the mathematical statement that compares two expressions on its that compares two expressions, let's say expressions using inequality symbols, and that's these guys here. Yeah, less than, greater than, less than. So yeah, so let's talk about inequalities per se. They are their own unique thing. All right, don't think about them as a type of linear equation. Inequalities are a whole different thing. All right. Okay, they're not they're not a type of linear equation. It's a whole different thing. So let's look at some of the differences between a linear equation and a linear inequality. So a linear equation uses an equal sign. All right. An inequality, you have an inequality, a linear inequality, if you see these symbols. All right. So an example of a linear equation would be y equals 2x plus 3. Yeah? And a solution to this is a line. Yeah, like this is a line. All right? And a solution to this equation would be a single point. All right? A solution to this equation would be any x, y point on the line. Yeah? Now, inequalities are a bit different. So, this becomes an inequality if I have my less than sign right there, less than 2x plus 3. Here, I'm looking at a region. This is a region of, I don't want to say space, but I guess for lack of a better term, we'll say space. All right? So, this is a region. And a solution to this inequality is any point below the line y is less than 2x plus 3. All right? So, and we'll see how that works, all right? Like, by solution, I just mean if I plug in a point that's in the region I'm talking about, this inequality will reign true, all right? And if I plug in a point on this line, any point on this line, inequality will be true. Like, this equality will be true, all right? So, anyway, let's get into it. So, graphing linear inequalities. So, what I like us to do, or what I like us to do when we see this question, is we have to, or at least what we need to know is that if we have y is less than 4, for example, if we have y is less than 4, this basically is telling us to go to 4, and because we're talking about less than 4, because we're less than 4, we are excluding the point 4, all right? This, I know we've already seen this before, but this is excluding, and This is including less than or equal to is including, and a dashed line tells us that we are excluding that particular point. Yeah? And then a full line tells us that we are including. So this we're given this inequality right here. Notice you have to be careful with your nomenclature. It's very easy to cause an equation, but it's not an equation, it's an inequality. So this the points that satisfy this solution is all y values that's below. We're saying below because we're less than, right? If you see less than, it just means below. Also, you could just think about it saying below. So everything below y equals 4. So if I plug in any y value here, this solution, this inequality will be satisfied. Like, let's say if I have y equals 3, this is 3 is going to be less than, 3 will be less than 4, so that's true. 2 will be less than 4, that's true. 1 will be less than 4, right? And that's true. But let's see, what if I plug in 4? Will 4 be less than 4? No, it won't be less than 4. So thus, that point won't satisfy the inequality. The only solutions that satisfy our inequalities are the ones below our positive 4. All right? And same thing for this question. Here we're including. So because we're including, hang on. Want a black line. Okay. Yeah, we're including here. We have a negative 2, and we want every point above negative 2, because here we're greater than. So I'd say greater than, more like above, or to the right of. All right, you see, like all the solutions that are to the right of my x is negative 2. And every point to the right of x is negative 2 will satisfy this solution. So like if I have, let's see. So let's see. X is negative 2. I'm going to have x is greater than or less than, it's greater than or equal to negative 2. That's true. What about negative 1? Negative 1 is greater than or equal to negative 2. So inequality is satisfied. So all these points, going till infinity make up my solution set. And here, all these points going to negative infinity make up my solution set. All right? So what about if I have a line? Well, same principle. On the same principle, if I see this here, how will I graph it, for example? Well, I have an intercept. My intercept is negative 1, so that tells me, nice. What else do I have? I have a slope, 1/3, so that just means rise 1, run 3. So rise 1, run 3. Right, I can go from here to here, and boom. I want this line to go through all 3 points. Okay, that's good enough for me. Let's make that a bit bigger. Okay, hold on, let me try again one more time. This. Perfect. Nice. So, I have my line. So, I don't want this to bend. Sorry. Just wanted it to be. You know what? Fine. Okay. So every point, so I'm saying y is greater than the equation of the line. So every point above. Now, so our inequality is y is greater than 1 over 3x minus 1. So let's look for, I'll pick 2. Our solution set is what's above this line. And by the way, we're excluding, so I hope some of you caught that. Oh, we're excluding. So what we need is a dashed line. We need a dashed line. Because we're just, because it says we are greater than, so we need a dashed line. So if I pick a point in this solution set here, like if I pick, because here I have an x and y, I need to pick 2 points. I need to pick, let's see if I pick x equals 0, because x equals 0 is there. If I pick y equals 1, all right? So then my y, let's see if this satisfies my equation. So my y is 1, so I say that's 1. It's going to be greater than 1. 1 is going to be greater than, so x is 0, so 1 over 3 times 0 minus 1. Y is greater than 1. Our inequality is satisfied. All right? And let's see. Let me see another point in the solution set. We have, okay, let me try minus 2 and negative 3. So my y is 3. I said negative 3, it's positive 3, sorry. My y is 3, and my x is negative 2 minus 1. All right, so I'm just plugging into this equation here. All right, I'm just plugging in our point 2, 3 into that equation above. So we're going to have 3 is greater than, sorry. I always mix this up for some reason. Minus 2 over 3 minus 1. I mean, that's 2/3 minus 1. So if I can simplify this a little bit. Minus 3 over 3. 3 over 3 because that's 1. And then it becomes 3 is greater than. I mean, these are fractions, but I can just, 3 is definitely greater than minus 5 over 3. All right? Because 1 is the same as dividing 3 over 3, I can do this. This allows me to convert this into a fraction. And I know 3 is for sure 5 over 3. Now let's try a point above the solution set. Just to show you how these things work. All right, just show you how these things work. Let's try 3, negative 3. Yeah? Let's try this point in our line. X is 3, y is negative 3. So if we have, let's see, x is 3. So I'm going to write my equation right here. Yeah, x is 3, x minus 1. So I know my x is 3. So it's going to be 1/3 3 minus 1 will be less than, that was my y. My y is negative 3. Let's see that minus 3 will be greater than 1 minus 1. Minus 3 will be greater than 0. Does not satisfy our inequality. All right? So that's how we should think about it. So every point outside the shaded region would not satisfy the inequality as it is. All right? So that's how we should think about it. And for I won't graph this, but I'm gonna show you something really important for part D. Let me show you part D. So if we come across something like this, our first instinct is to convert this to slope-intercept form. All right? That's the first instinct. So if I have 4x minus 3y is going to be less than or equal to 12, I can take the 4x across, convert it to minus, 4x is going to be 12 minus 4x. Then I divide by negative 3 to let the negative 3 alone. Cancel that, cancel that, cancel that. But you see, there's an important caveat here. All right? This is a mistake that many people make, that even I made in class. Every time you divide by a negative number, and here I'm talking about dividing the whole equation, all right? Anytime you divide both sides of the inequality, so anytime you divide by a negative number, let's see, in particular, both sides of the inequality, or even multiply, comma, you have to flip the inequality sign. You have to flip the inequality sign. So you see, I'm dividing by a negative number. I'm dividing both sides by a negative number. So this becomes y is going to be less than, it's going to be greater than 12 over minus 3. It's going to be minus 4 over minus 3x. All right, and then the same process we did there. You graph the line and you determine the solution set, and then you determine what's not in the solution set. So yeah, so that's the point of graphing linear equations. So now, what should I do when I come across something like this? Here now I'm being asked to graph the inequalities. Well, two ways. There are two ways of doing this. All right, two methods rather. So two methods. Well, really, we have to remember we're really graphing the line there, but remember we're going to have an inequality symbol. All right, so but it's a line here, so it's the same thing as graphing a line, but instead of an equal sign, we're going to have an inequality symbol. All right, so the instruction is, given the graphs of inequalities below, write the equations. So so now what we can do here, we need to find the slope and find the intercept. Two ways to get the slope. So two methods to get the slope. We're going to have m equals to y2 minus y1 over x2 minus x1, or rise over run. All right, rise over run is a bit risky. You can make some mistakes. I would just get 2 points on the line and then use this to get the precise slope. All right, and then to get the intercept, so two methods to get intercept. All right, to get the intercept, number one, look at the graph. All right, look at the graph. If you look at the graph, you can see where the intercept is, but sometimes you may not see what the intercept is. In that case, use point slope form. All right, point slope. This will give you the equation of the line, the whole line. If you know the slope, which you can get by either rise over run on this form, then you can use point slope form to, because if you know the slope, you can figure out a point on the line by looking at whatever points you have on the graph. All right, and then that will give you the equation of the line. All right, so if I have this right here, let me do a quick example. I'm going to use the rise over run because it's a bit risky. So as I'm going to the left 1 and rising up 2. So my slope is minus 2. So my line is minus 2x. That's my intercept, minus 3. And that's my equation of my line. Remember, it's not an equation, it's an inequality. So I'm talking about all the points. Am I above or below? I'm clearly above. I'm above every point on this line. because my shaded region is to the right of it. All right, so I'm above. So my y is greater than minus 2x. So minus 2x minus 3. Awesome. And greater than or equal to, because it's a whole line, I'm including it. So I'm including the point. And the points in the green region should satisfy the inequality. The points that are not in the green region won't satisfy the inequality. If I do this one, well, same thing, even though it's dashed, same thing. So I have, I get 2 points. I'm going to use m equals y2 minus y1. So let's see, I have a point here. My x is going to be 0. My y is 0, and my x is negative 3. X is going to be negative 3. Y is 0. And then, let's see, what else do we have here? What other point can I get here? Simple one. My x is 0 here, and my y is 2. Awesome. So now, this is going to be x1, y1, x2, y2. Then I have 2 minus 0 over 0 minus 3. Yeah. So my slope is going to be 2 over 3. Yeah? Yeah. So now I have my slope. So I know y is, well, this is clearly below, because I see my y values are below my line. So this is below. So I'll say this is less than 2 over 3x. But this is pretty simple to find the intercept. I could use points low, but I can see the intercept. So if you can see the intercept, just look at it, and it's positive 2, so plus 2. And that's your line. Less than or equal to because of the dashed line. All right, so that's our lesson on inequalities and what they really mean.